Welcome to WeAreDevelopers Live Week 3rd edition. What does 3rd edition mean? It means there have been another 2 editions. So right after you watched all of this, you can go through the first 2 weeks. This is just if you are new. If you are already known, then you already know us. Unfortunately, due to this year's event, we cannot be in Vienna's Hofburg today. Otherwise, we would be there and drink coffee together and then watch the keynote or go to the first workshop. But so we are here. Doesn't matter because the Vienna Business Agency and the city of Vienna are the main sponsors of this week. Today is sponsored especially by Couchbase. At this point, I also want to thank all of our partners, the partners who are making this thing possible with money, with supporting through giving talks. And I also want to thank our media partners, who always help us to spread the word. And I want to say thank you, last but not least, to our community who always helps us to find the right topics, to find the right speakers, and to be there for discussions, questions, answers, and everything else. So today is about DataWorks. So yeah, bread and butter of software development. But that's enough about us. Now let's have a short glance at you. There are among the participants 88 different nationalities, if I remember correctly. And you will have the possibility, if you are on the website, on this side, to use Slido for Q&A and to participate in the polls. So always make sure to have a look at this thing here. What does it mean on the webpage? You have to go to wearedevelopers.com/live-week to see what is there. You will also find the agenda so you can browse through the rest of the week and pick the cherries which are suitable for you. In parallel to this stream, there is also a coding for kids in cooperation with DaVinci Labs going on. So if you know of any kids 9 to 16 years, head over to the webpage wearedevelopers.com/live-week and find out more. And just 2 more things from my side is on Wednesday, you will also have a cool virtual guided museum tour through the Albertina. So you can pretend to be a tourist in Vienna, and this will be also one of the not so developer-y highlights of this week. There is one more thing. In the wrap-up mail every evening, there is a survey. If you take part, you could win Amazon vouchers or 1 out of 30 goodie bags powered by the Vienna Tourist Board. And you will also find the survey on the website later this afternoon. The last word before I introduce you to the host of today is about the code of conduct. So for the code of conduct, there are 2 versions. This is something I always say. There is a short version which says, please behave and treat each other with respect, and the long version which goes something like this. So, hello Stefan, good morning. How are
Hello,
you?
everybody. Hi, I'm
Uh,
here.
yeah, that's good. So, Stefan is from Couchbase and he will guide you through the rest of the day. And I will now turn off my camera and microphone and have fun, guys. Have fun, Stefan.
Thank you, Stefan. So, hello, everybody. I personally also welcome you to this first day of the We Are Developers week, Data Works. I am very proud to can speak to you here as a moderator throughout the day. This day is sponsored by Couchbase, which is a modern distributed data management system. My name is Stefan Schneider and I'm leading the solution engineering team in Central Europe here at Couchbase. And I just want to highlight quickly what is this sponsor about. So Couchbase is headquartered in Santa Clara, so coming from Silicon Valley, and also here with a large global footprint, also here in Germany, in Central Europe. And basically serves mission and business critical applications around the verticals around the globe, not only in labs, but for sure well known in many market leading companies. And that is basically what it's provisioned. Yeah, so a whole data management platform, fully infrastructure agnostic. And yeah, well, as I said, I'm the moderator of this day. And despite the fact that our next two guests, Timo Lackmann and Julian Storz, which are two solution architects from MongoDB, despite the fact that both companies have competition in the same market, I think the main point that unites us is that we are system of the future, modern systems in contrast to RDBMS, and also both systems are document stores based on JSON. So I'm really glad to also can see your talk, Julian and Timo, which is all about your system, your way of doing it, and I'm excited to see how you model data, how you query this data, and I hand it over to you. Have fun, guys.
Thank you very much, Stefan. All right. So let me request a control for short from Timo, such that I actually have the full access to his screen. Because today, what we're going to do is we're going to go hands-on with you. So this is really meant to be as interactive as possible, despite the situation that at the very moment, everything has to be remote. As it was already stated, we would have loved to be with you in a room, but due to the given situation, we just make the best out of it, and we'll promise we'll keep it as interactive as possible. So today our talk is going to be from zero to hero with queries and real-time indexing. So how can we make this easy for you as developers such that you can focus on what is most important to you, which is driving code, which is developing applications. And just for short, in the beginning, I just wanted to highlight that this is going to be a hands-on webinar. So we are going to show you directly how you can set up a cluster for yourself. And then we are going to use the cluster that you have generated yourself to actually start and query some information. We're going to set some indexes together and just guide you some of the specific basics to work with MongoDB. And the really nice part, due to the fact that it's a hands-on session, we really wanted to make this a challenge. We really wanted to make this interactive. And thus, if you are participating in the challenges that we're going to showcase to you later on, actually, this is going to be the part that Timo is taking over, you can actually win some prizes. So what you can get is either a MongoDB surprise package or a yoga mat. So it's definitely worthwhile to stay tuned and to later on participate in the hands-on part. Timo will give you some more instructions on how that works and how you can participate later on. So Actually, I skipped the introduction part. Let me take that here for a second before we go through the agenda. I'm Julian. I'm a solutions architect, as Stefan already mentioned, with MongoDB. And Timo Lackmann, he's a colleague of mine. He's also working with me in the same team, also focusing here on the DACH region. And we're working together with enterprise customers to help them design their solutions and to think about how they can actually design their modern applications and how they can move forward with this. And we really want to go through with you first some of the basics today and really think about why you should actually think about using NoSQL technologies, why MongoDB in particular is a very interesting choice for the future. Then we're going to go into a hands-on part. So we're going to set up an environment for you, and then we are going to introduce you to how you can work with the tooling that is provided by MongoDB, with the database, how you can make queries, and then we go into the live chat that you can apply what you have actually learned throughout the session. So one more thing before we then actually get started with the basics is our MongoDB.live. This is our annual conference here specifically for the DACH region, MongoDB.live DACH. It's starting, it's taking place on the 8th of December and it's starting at 9:30 a.m. And the really important part is that today we're going to give you a broader overview, some of the basics all around MongoDB and some introductions. And if you really want to go deeper into the weeds and if you want to get to know more details about MongoDB, if you want to get to know some of the experts that are building some of the parts of the core server and things, this is definitely the way to go. We're giving you an outlook on the roadmap on what is happening. And the great thing is, due to the fact that it's COVID situation, we need to make the best out of it. So it's free, it's online, and you can register here very easily. And Regina also just posted a link into the chat that you can use to sign up there. So without further ado, let's get started with some basics all around MongoDB. And first of all, I just wanted to highlight for short, like what MongoDB is currently doing, how we are developing as a technology. And as you can see on the top left corner, this is our historic downloads. And as you can see that MongoDB's adoption is growing at a very fast pace. And actually, we do expect that this year in 2020, we'll need 150, 160 million downloads of our core server. So why is this important? It's simply important because that means that the adoption of the technology is very broad. And you can also see this in the DB Engines ranking. This is a ranking from DBAs, where you can see that MongoDB is currently ranking number 5 out of all the different database technologies that are listed there. And the interesting thing really is that it's the only NoSQL technology that is ranking amongst the top 5, top 6 database solutions. So it's really the first one that is coming into place. And another thing that I think is very interesting, specifically from a developer standpoint, is that MongoDB has been rated the most wanted database by developers within the Stack Overflow surveys. So that's just something that's really nice. And we're going to cover why this is the case in a second. So let's actually jump in and look a little bit at how things have been changing over time, because I really think if we want to look into the future, it's really important to also take a look into the rearview mirror and understand where we are today and why we are where we are today. So if we're looking into the past and if we're thinking about where we are coming from, and specifically within data management, it all comes a little bit around the relational model. The relational model was really invented in the 1980s. So in the 1980s, computers were big. They were literally the size of my room. I mean, you can't see the room right now that I'm in due to my background, but you can imagine like these huge machines that were necessary back then. It were single tenant applications. And what was really important is that hardware was only available in a very limited fashion. So if you wanted to change something due to the fact that the applications were mainly meant for only a single tenant or like 2 or 3 tenants, what you had to do, you had to scale up. And the most scarce resource back then, and also the most expensive and limiting, was storage. And that's why the relational model is really meant for optimizing the footprint of storage on disk. So let's have a look actually and look at why we really did this in the past and why the technologies are really designed for this specific use case. So here I have a chart for you that shows you the development of storage prices over time. And as you can see, in the 1980s, when the relational model was invented, you paid approximately $100,000 US for a single megabyte of storage. I mean, today, this is unbelievable because we kind of get storage for free. You get 15 gigabytes when you go with Google Drive. You get like infinite storage for your pictures with Google Photos. If you're signing up with the Apple Cloud, you get a couple of gigabytes. Like wherever you go, storage just got pretty much free. But there are other challenges, and things have changed also when it comes to the perspective of data management. And today, what is really important is that we are moving fast, that we're developing application features fast, that we're flexible, that we can introduce new things. Agile is of the day that people literally make deployments on a single day basis using CI/CD, and everything must be integrated. So we really need a data model that allows us to have this flexibility, to adjust new features, to add new data to our database as we go. And the second thing that is significantly different from back in the days when the relational data model was invented is that today our applications are global. So it's not that we're in a single room having these big computers, it's more that we have users all over the world. So it's really important that we can scale horizontally, that we can get our data close to our users such that they have very low latencies when it comes to read and writes in their applications. So to sum this up, this is most likely the view that you have today. You have in most traditional software projects, in most traditional deployments, you have hundreds or even thousands of tables that form this very complex entity relationship model, which you then have to work with, and you have to add features in a very strategic manner, adjusting your schema. And sometimes if you're updating certain values, you need to make an impact analysis, and you need to really sometimes even take the database offline such that you can add new values to a single table. And if we put this on a more semantic point of view, then we actually have this view on our data and on our applications today. On the top layer, we have our objects. Those objects are the domain entities. They are the business objects that we're discussing. And then on the lower level, we have the way that this data is going to be persisted on the persistence layer, on the database layer. And as you can see, those objects that we have then have to be split with an object relational mapper, or sometimes you do it manually, whatever you want to choose, but you have to split these objects up to then persist them on the database layer. And if we're looking at this from an application point of view, this is what it then looks like. We do have the situation that from the application point of view, we have the tables on the left, which is this complex rigid schema that we have been looking at before. And then we have the application on the right. And usually what we do have is we have some sort of an API that is then communicating with the application, no matter whether it's a mobile application, whether it's a desktop application, but we usually work with JSON in the application side or a similar, more object-oriented structure. And so we have a clear mismatch. So for example, if you are thinking of a simple application where you can store the cars that you're renting, and obviously here it's a little bit more luxury cars, that is more interesting. So if we think about that, on the relational side, we have now multiple tables with a person table and a car table, and we have to make these joins. So you have to go to the person table, you have to look for the information about a single person. So in this case, Paul Miller. Then you need to take the person ID, go to the car table, look for the two rows that have the person ID 0 in this case. Then you need to join the information together, just that you get the object back that you then can use in your application. So this obviously is a lot of overhead because you have multiple access on indexes, you have multiple access on the tables, and then you need a lot of compute to actually just get this information together to then provide it to the application. So how can we do things differently? From the MongoDB perspective, what we do have is we have the objects in our applications and the business objects, and we try to persist this information directly to say in the database. So we make it much more easy, we want to make it much more native to work with data. And if you're now looking at it again from a more application, from an application perspective, we now have the situation that on the right-hand side, we have our application again. And in the application, we're using our JSON format that we had before. But now what we can do is we can directly store this information in our database. And obviously now there are all the times the questions, okay, but how about like the JSON structure? Do I need to parse the data? Like, do I need to kind of do something on the application side? And this is really the nice thing about MongoDB, because in MongoDB, we store the JSON in a binary format. So all the fields are typified. So if you have an integer, you can store it as an integer. If you have a string, you can store it as a string. If you have a decimal, and even if you want to make very fine-grained calculations with your data, we provide you with a decimal data type, such that you can store this information and you can make calculations without any losses very easily on the database level. And additionally, no matter how rich your data structure becomes, so if you want to nest certain information, if you want to have multiple entries in an array, you can access all these different fields in MongoDB, no matter where they are located, no matter how deeply nested they are in the data structure. And this obviously comes with a lot of advantages, because having such a JSON structure, having such an object-oriented approach, gives you also the flexibility to adapt changes very easily and very fast, because MongoDB, as most other NoSQL technologies as well, do support polymorphism out of the box, such that if you have a lot of people in a specific collection, this is what we call like a collection of documents, so it's literally just directly taken from that word. Every single document can look slightly different. For example, some person can have only a landline number, additional people can have a mobile phone number, and they can live right next to each other within the same collection. So this is absolutely no problem for MongoDB at all. That means that MongoDB provides you schema flexibility. But this doesn't mean that MongoDB doesn't provide you any schema at all. If you want to, you can structure a JSON schema on the database side, such that MongoDB is enforcing for you certain structures that you are providing to the database that you want to have from the application side. So this can be that you want to have a certain data type for a specific field, or this can be that certain fields are mandatory and must be part of the document. And otherwise, the database either sends a warning or is fully rejecting the write operation directly from the database side, such that you get an error back and can tune it. And that's a very nice thing, because if you think about it, depending on where you are with your application development, you can now enforce a schema such that, for example, if you're moving to production, you have certain guarantees also from the database side that the data looks the way it's supposed to be. So you're thinking about it like with a duration aspect, you can just increase the governance that you want to have on your data in the database level. And also, all this information that you have in MongoDB is fully indexable. And we do provide a vast range of strategies on how you can use indexes in MongoDB. So every document by default obviously has its primary index, and this is unique such that you can make fast access on a document based on its ID. But also we do provide you with compound indexes, to indexes with multiple keys. We have wildcard indexes, which we just talked about, polymorphism, that like single substructures of documents can look differently. And with wildcard indexes, you can make sure that even if you add new fields, they will be indexed and they will be accessible fast for you. We do provide you with full text search indices in our managed service solution, MongoDB Atlas, that we're going to use later on. We have hashed indexes, but we also have strategies like time to live indices that automatically delete certain information from your database based on timestamp that you provide. There are way more strategies that you can use, but the really important thing is like all these indices are real time, they're synchronous, and they're building directly on the Mongo daemon, such that you can be ensured that if you're setting an index, that it will be up to date and it will be consistent with the data that you're having without the need of like adding any other like complex features or having to add like new columns or things like that to your data structure. So why is all of this so interesting, and why is all of this so important to have a look at right now? One of the main and really important reasons for that, and this is also something that I have mentioned a little bit earlier, is that the way that we work with applications is changing. And one of the current trends that we see quite frequently and that we see often is microservices. So more and more companies are moving towards microservice architectures. So why are microservice architectures such a good fit for NoSQL databases and such a good fit for MongoDB in particular? The reason is that services are usually working with specific entities, with specific domain objects. So for example, a shopping cart or a customer. And those kind of objects can be represented very nicely and very easily in a JSON format. But now the question, why is JSON actually the right choice for your data interchange? And why is JSON so important in our days? And this is literally because, and on the left side, you can see statistics from Stack Overflow. This is because JSON has become the de facto standard to work with data in data interchange and between systems. So most REST APIs are currently JSON based. And the reason for that being is that the evolutionary path of the internet has been going through JavaScript very intensively. And JSON is the JavaScript object notation, such that it has become a very native thing to adopt the JSON standard very widely, specifically when it comes to application development and when it comes to data interchange. So now we have understood a little bit like why it is currently interesting to look at MongoDB, why things have developed the way that they have developed, and why JSON specifically is so super interesting when it comes to data interchange, to REST APIs, to microservices, due to flexibility and all that things. But the question really is, what can you now do with a database like MongoDB? And today in our world, versatility is really important. And when we work with customers, oftentimes what we see is that technology stacks become more and more complex. So you have all kinds of different technologies on the market at the very moment for data persistence. Relational technologies, key value stores, data lakes, graph databases. So it becomes really verbose when you're thinking about how applications are developed nowadays, because for all these technologies, you need to have people, you need to have the specific knowledge, you need to know how they work, how they are supposed to be operated, how you develop with them such that you get most out of those technologies. And this is why MongoDB, with the rich data structure that we do have, we do also provide a lot of versatility when it comes to actually accessing the data and working with the data. And this specifically is part of our rich query language. And we do have features for relational. I just already mentioned we are always indexing a document with a primary key such that you can access it really fast. We have full text search. We have Lucene integrated into MongoDB Atlas such that you can have full text search queries very easily directly on the data that you have on your database without needing to build a search index. We do have an integrated data lake, which means that you can outsource your data from the MongoDB cluster directly into an S3, and you can make federated queries to both the hot and cold data very easily and seamlessly, such that you can make operational analytics very easy and very cost effective. And we also have graph queries. So now the question obviously is, this is a little bit a marketing slide. Can MongoDB provide 100% of the capabilities that all of the technologies, all of these specialized technologies that I have been showing before, can MongoDB cover 100% of these? And let's be fair and let's be honest with you. MongoDB is not a silver bullet. So you will not be able to do 100% everything with those technologies. But what you can do is you can cover 80 to 90% of those different features and functionalities that you need. And most oftentimes, this is more than enough to cover your projects and your development initiatives. And I now want to show you specifically for the relational case with the features that we have been adding over time to the core server and to the database, how we actually have evolved and how we made this possible such that MongoDB can be used in so many different use cases easily and natively. And here you can see the evolution of the MongoDB server and of the MongoDB ecosystem. So this is really from 3.4 to 4.4. So this is approximately the last 5 years of development. And it's incremental feature adds. So 3.4, what you can see is those are the features that we've released with 3.4. And as you can see, this has been increasing consistently over time to 4.4, where we have released more features than ever before. And they're specifically community driven to make sure that we really cover all the needs of the developers. There's also feedback pages that where you can enter your own feedback requests, which is like feedback.mongodb.com. And those things are then directly taken into consideration to work on the backlogs for our developers. But back to the relational part. when I'm looking at 3.6, for example, we have added joins, which is called expressive dollar lookups, to our MongoDB query functionalities. So you were now able to join information between different collections together. So that was the first step. In 4.0, we added ACID transactions because we realized, hey, there are actually situations where we do need ACID guarantees with multiple documents on the database level, also in the NoSQL world. Because similarly, as with joins, we really try to avoid joins, for example, but there are situations where it's necessary, and then obviously the database should support that. In 4.2, what we introduced is distributed transactions. So now you were able to make ACID transactions in a sharded, and we are looking at what sharding actually means, because sharding is our way of horizontally distributing data. In a sharded cluster, in a horizontally distributed cluster, you are now able to make ACID transactions. And in 4.4, we added union, such that you are now able to partition your information in different collections, but still get all the information together, extend your documents such that you can make a full overview analysis of the data that you have stored, but still get all the benefits of cutting some partitions, reducing the length of your indexes, and having faster access to data when you need it. And this is really how MongoDB is powering mission-critical workloads today. On the one hand side, we have all the traditional relational strengths that we have moved into the core server, into our database. And on the other hand, we have all the benefits from NoSQL, all the benefits from a document-based, big data oriented, horizontally scalable database. And we really unified them into one solution such that you can use it for your development projects, and you do not need to have like such a zoo and such a broad scale of different technology to actually fulfill your requirements. The point that is now open really is, how can I actually make use of this? Because it's great if you have all these capabilities, but if it doesn't support my ecosystem, then obviously this is a big problem. So let's look for short at how you can actually access your data with the different drivers, with the different frameworks that are out there. MongoDB overall has over 30 idiomatic drivers for all different kinds of programming languages. And we've also, for example, now released a Swift and a Rust driver because there was demand from the community. And this really just shows that we really try to always keep up with the pace and with current trends in developer communities to make your life as easy as possible. Then we have different components that actually integrate very nicely into current ecosystems. So for example, if you're currently leveraging a traditional BI tool that is SQL based, we do have a connector for BI such that you connect those kind of applications, those reporting tools to MongoDB directly, where we translate the SQL queries directly to a MongoDB query. We have MongoDB charts to visualize this kind of data directly, natively on the database. There is a connector for Spark to allow you to use distributed computing specifically for large-scale machine learning applications. And there is a native integration into Apache Kafka, such that you can use MongoDB both as a sink and a source to allow you to build very nice asynchronous event-driven applications. And one very important part, which is MongoDB Compass, it's our open source graphical user interface to work with MongoDB, which is also going to be used later on. And I'm going to give you a short introduction on the tool and where you can download it in a second. Because before we go hands-on, before we're actually going to start working with it, I would love to give you a short overview over the architecture of MongoDB, such that you actually know what is happening in the background, because we really focus on the development side of things today. But I think it's really important and necessary to understand where these kind of capabilities are coming from and how the architecture looks like, such that you can also benefit to a really high extent from what the technology actually has to offer. And here, to give you a short introduction to two things, which is high availability and which is scalability. Because MongoDB, as I have mentioned now a couple of times, is by default a distributed system. Why is this the case? MongoDB stores the information that is accessed together in documents. So we really try to keep all information that we read together in one single place. So latency with respect to network latency is not as critical to MongoDB as it would be in a relational system where you join all the information together from different tables. That means we can very easily distribute data over a lot of servers without having any kinds of negative impacts. And this is how we actually have structured the overall database. So as you can see here, the architecture in this case is pretty simple actually. All nodes are the same. So we have multiple of our MongoDBs, and in an optimal case, we also distribute them over different availability zones. This is also the way that we do it in our managed service or different data centers, such that you really have highest availability possible. And within our architecture, we always have a primary server, and then we have multiple secondary servers that are replicating the data directly from the primary. And this is a streamed replication process. This means it's very fast and very efficient. In the application side, we do have a driver, one of the idiomatic drivers that I have been naming before, and those connect directly to the primary, and they know the full replica set. So once they are connected to the replica set, they write and they read from the primary server. That means we do have strong consistency by default. You can also read from secondary servers at the expense of having the strong consistency, because obviously the data needs to be replicated. And even though there is a very short replication lag, by definition, it is eventually consistent, so it must be known. And now the great thing is that in case that the primary fails, one of the secondary servers automatically takes over the function of the primary server. And this kind of failover typically happens within 5 seconds or less on average. And the nice thing then is that the secondary is taken over the functionality of the primary server, and the application can just continue working as usual. And in between this very short period of where there is no node available for the writes, the driver is actually handling this for you. If you configure it, it's very easy. So you have retrievable reads and retrievable writes that the driver is taken over for you, that in case it cannot finish a write, for example, it just retries this write application after a short period of time to make sure that none of your operations are failing or are going lost in the overall process. So this way, your application is always up and running, and you can be ensured that it is all taken care of to have the highest availability and data consistency possible. And now the second part, which is the lower two secondaries that are marked blue, is something that is oftentimes overlooked, but I think is extremely interesting, specifically when it comes to modern applications where we want to leverage operational analytics. Because the great thing about MongoDB is that we can provision additional secondary servers that will never become primary server, but that are replicating the data directly from our operational data, or from the operational database. So what you can do now is you can connect with analytical applications to the analytical secondaries that you have on the bottom. You can hit them hard with very long running queries, but you will not affect your transactional database by itself. We call this workload isolation, and it allows you to have analytics on your live data without having any impact on the read and write performance of your transactional database. So to sum this up, the replica set allows you to have tunable durability and consistency. You have the freedom and the control over how durable you want to have your data, how fast you want to write, and whether you want to have also allow for eventually consistent reads to make more use of your architecture to get best performance out of that. And it also allows you the kind of way that I described with the failover. You can use exactly the same for upgrades, patching, scaling. And this means that you have near zero downtime for all kinds of maintenance processes that you're doing. Because you can simply make a rolling upgrade. You can first upgrade one of your secondary servers, then the other secondary server, then you initiate a failover, and you can really leverage this kind of high availability architecture for all kinds of processes. And this is the high availability part. But what about disaster recovery? Because if my data is corrupt, then obviously high availability doesn't yet solve the problem. And this is where our backup concepts come into play, because we have for both our cloud solution as well as our on-premise solution, we have solutions to allow you for point-in-time restore, where you can specify exactly to which point in time you do want to restore your MongoDB such that you actually have an RPO of a minute. And this is really important for mission-critical applications, specifically when you're working with customer data and you really have to make sure that you lose as little time as possible from the point in time where data corruption has happened. Or you simply restore, in case of the cloud, you simply restore to a new cluster and then you just take out the information that you want, because we have, due to the fact that we're using attachable snapshots, we can restore terabytes of data just in a couple of minutes. And this makes it very easy and very simple. And as already stated, specifically when it comes to the cloud, using this high availability architecture for scaling at any time up and down, however you want it, also in an automated fashion to make sure that the database is always scaled to the right size, that it covers your application needs to the best, is all taken care of. And talking about scalability, I mean, we now talked about vertical scalability. This is not necessarily anything new. But what is really nice about MongoDB is that you can also scale horizontally. So you set up multiple of these replica sets where all of these replica sets by itself are obviously highly available. And then you can distribute your data over these different replica sets. So each and every of these replica sets, we call them shards, in such a sharded environment, contains a certain chunk of your overall data. And you can choose how you want to distribute your data. So you can either make it hash-based to get as much write throughput as possible. You can make it range-based. So you could store customer A to customer F in shard 1, customer G to customer N in shard 2, and so on. Or, and this is something that our customers find extremely interesting, you can do it zone-based. So you can say, for example, that shard 1 is in the US, shard 2 is in Europe, and shard 3 is, for example, in Singapore. And you can then define which documents are supposed to go where based on a tag in the document. So for example, US is automatically routed to S, EU is automatically routed to Germany, and SG is automatically routed to Singapore. And the nice thing here is that we now have write locality. So if people in Europe write, they write obviously to the shard in Europe and get very low latencies. If people in the US write to your database, then they write to the US shard, which also provides you low latencies. And the same with reads. But moreover, it also allows you to comply with different data regulatory setups. So for example, GDPR requires you to store your data in Europe. Russia has a similar setup where you're not allowed to move customer information from Russia out of Russia. Turkey, China, and even California adopted the GDPR standard and made it even more strict than GDPR itself. So it becomes more and more relevant to actually allow for data locality. And this is exactly where this feature comes into play. And the great thing about MongoDB is that we not only allow you to store your data anywhere, but to also run the database anywhere. So no matter where you are, whether you're locally, on premises, private cloud, hybrid cloud setups, or in the public cloud, we provide you with a way to run MongoDB on like enterprise scale if needed. And this becomes like a very nice thing because here, as you can see, we have also integrations into most of the currently used infrastructure frameworks, be it OpenShift, be it Kubernetes in general with a Kubernetes operator, and the public cloud. And specifically today, and also for the workshop and the hands-on part, we are going to use our public cloud service, MongoDB Atlas. And MongoDB Atlas is our multi-cloud offering that we provide where you can get MongoDB fully managed as a service directly from us. And we have over 20,000 customers that are using the service since more than 3 years now. It's available on AWS, on GCP, and on Azure, and we have over 1 million clusters deployed. So it's literally crazy how this has taken off over the last couple of years. And the nice thing is that you cannot only deploy your database on one of the specific cloud providers, but you can also use real multi-cloud. So you can have your main replica set in AWS, and you can have one of the read-only secondaries that I've been showing you earlier in the architecture on GCP to leverage the analytical services of GCP, specifically when it comes to machine learning or similar. And this is really nice because we're taking care of everything that has to happen in the background to make such a setup possible. We give you full flexibility to migrate between different clouds if needed, and you can leverage all the technological advantages with your data in real time on the different cloud providers. And this is exactly where we're now going to dive in. We're going to look at our data platform, which has the data foundation with MongoDB Atlas. We have full text search, we have the data lake, and we have all kinds of additional features and functionalities, triggers, functions. We have even a mobile database, MongoDB Realm, that you can use and sync your information bidirectionally, including the conflict resolution, both for iOS and Android, natively integrated into your different application frameworks. And to actually work with MongoDB Atlas now, what we're going to do is we're going to take MongoDB Compass or the MongoDB shell, whatever you prefer, and we're going to start working with some of the things hands-on. We do advise you to choose MongoDB Compass for the session because it gives you a visual interface that you can use to work with your information, to modify, delete data, and also to optimize your specific environment, your databases and collections, setting indices and things like that. It's a great tool that gives you a lot of guidance. But Timo is going to give you a more deeper look into this. And this is also where I would like to hand over Timo. I'm going to post you the 2 links to MongoDB Atlas and to Compass in the chat now. And Timo, can you please give us a little bit of deep dive hands-on with MongoDB?
Yeah, thank you very much, Julian. So before we start, I would actually like to know a little bit about you, the people who are participating. And I would kindly ask you to participate in the poll that we've prepared, just some basic questions on who you are and how you might be experienced with MongoDB, just so we know where we need to dive in a bit more maybe. Can we actually get all the questions now from not only the first poll, but actually all 3? Otherwise, please let me know when we should look at the results.
There comes the second question.
Yeah, thank you very much. And who might not have done it and has done the poll, please, of course, feel free to create your account on cloud.mongodb.com. So you're ready for the next hour.
And here's the third question.
Yes, thank you very much.
Guys, just a quick question from my side. Do you prefer to answer the continuously incoming questions throughout the external Q&A tool directly or as a summary at the end? Because we do have already 3 questions that is related to the talk of Julian.
I think that would be a good point now to actually address the questions rather than at the end, depending on how complex they are. Julian, if you don't disagree.
I'm absolutely fine with that. If they don't ask me for the question like where everything is rooted, this answer is 42. This answer is 42. I rely on things that have been given to me previously.
Okay, Julian, then I would start with the first one. If the system is absolutely available for mission critical applications, why is then backup that important at all?
Yeah, that's a really good question. So the thing is the following. We have to differentiate between high availability and disaster recovery. So for example, if I have my 3 cassette and my primary server fails, then one of the secondary server takes over. So everything is fine. But what, for example, if you knock on wood that this will never happen, but if you have a query that deletes, for example, specific information of all the customers that are called Timo, and now Timo wants to log on, then obviously Timo is very unsatisfied. And the problem is if this only happens to a couple of your customers, let's say you only deleted Timo Lackman, which is very unfortunate for Timo in this case, but this is something where you could ask the customer to re-enter his specific information. But if this happens to 10,000 customers, for example, you need a way to restore the information that would have otherwise been lost. And this is exactly where, for example, this disaster recovery comes into place, where you need to have a backup such that you can specific information, because high availability means we stream the information to the secondary, and then obviously the wrong information is then highly available, but obviously wrong.
Okay, thank you, Julian. The
Sure.
next one is horizontal scaling, so-called sharding, available on community version for Kubernetes?
Yes, that's absolutely possible. So sharding is not an enterprise feature. You just have to say that sharding obviously is a complex architecture. So if you're using sharding, then things like backup become, for example, pretty complex, because we now have a situation where we have multiple shards. We need to keep the time of the different nodes in sync. We need to have a snapshot where you want to obviously have a consistent snapshot in your backup situation, and you need to orchestrate the overall setup. So it's not an enterprise feature, but we do definitely recommend, given the different setup and what you're working on, to look at options that make your life a little bit easier on the operational side.
Thank you. The third one is, what hardware resources replica sets represents? What do I need to consider with more replica sets? What you call primary and secondary?
Okay, that's a good question. So I really like the question, because oftentimes there is a question, so if secondaries are only there to copy the data, why should I have, for example, the same size of server? The thing is that what we do say as a best practice is that all the different nodes are sized exactly the same. So for example, if you are having a primary with 16 gigabytes of RAM and whatsoever, then you should have the same as the secondaries, because obviously the secondaries could potentially become primary. So when we talk about nodes, what does it mean? Technically, the node is only the process. Yeah. So you could run a replica set on one computer, but then obviously if the computer fails, then the high availability doesn't help here. So you really have to take into consideration what you want to achieve. Best practice, you take a different physical node or a different VM for all of the nodes, and you should try to make sure that the single nodes are as independent as possible, to make sure that in case, for example, your rack burns down or you lose electricity in the data center, Stefan, you're laughing like this is, it sounds funny, but there is a reason why we both smile. Such situations happen. We just had an outage with AWS, for example, and you need to make sure that you are as resilient to such situations as possible. So deploy to multiple availability zones, deploy to multiple regions if it's really necessary and critical, or in our case, even deploy on multiple clouds, such that you're also independent to, for example, an outage of an AWS.
Great answer, thank you. And the fourth and last one so far, building the table schemas into the database. Some good examples: accounting software basics, stores, cards, stocks, debitors, creditors, purchase, inventory, etc. So I think I need to translate this question a little bit. I think the main intention is, where do maybe provide some good examples to play around it?
That's the best question ever. Timo, in this case, Timo is laughing because this is exactly what we are going to talk about on our annual conference. So on the 8th of December, Timo and I will have a talk on how you can actually structure your documents, how you can get best performance out of a situation. And this is exactly where we talk about how you can actually structure your different entities, how you can link them together, how you can build a collection and a document schema that gives you best performance. So highly recommended in this case for that specific questions to simply sign up for the talk. And obviously, please feel free to reach out via email after the talk if you have any further questions. If you have like something specific where you want to make a deep dive on, we're happy to help to provide additional resources. Just feel free to contact us directly.
So we can say it's basically part 2 of what we see today.
If you want to say it like that, Stefan, we can say it like that's part 2, because it's the same team, it's the same 2 people.
Okay, great. Okay, so I think that is also a good transition to Timo now. Yeah, I would say just proceed, because there are no further. Oh, wait. Okay, one more. In microservices architecture, is there a limit as how too many applications can simultaneously query the single database?
That's a good one. So Depends on the scale of the database, I would say. So obviously, if you're thinking about microservices in a sense of like we have projects where we have like hundreds of databases literally for different applications. I mean, Stefan, you most likely have similar experiences. But usually, such databases tend to be very small, but you have a lot of them. If you are having a single database or a single application that is serving too many collections, then you actually should think about whether not yet again building another monolith. So you're just building a microservice, but this microservice just grows to infinity and then becomes mission critical for all the other parts. So this is really an architectural design question where we could like discuss and philosophieren like for yet another hour or something. But I really would say like the biggest cluster, like the single replica cluster, the biggest one that we have on Atlas, I think supports 128,000 connections, 150,000. So if that works for you, then you should be absolutely fine.
I think that should be good enough. Okay, now not stealing more time from the demo part, I would highly recommend to proceed, Timo.
All right, great. Yeah, no, thank you very much for the questions also, because I think it's important to tackle these questions because they are not uncommon questions. They are the general topics that come up, and it's important to address them. And also regarding the examples on the data and how to set them up, as Julian said, one thing is we will have a deep dive talk next week where we describe how to get to let's say a good schema or a good document design. And today during our hands-on, you will actually already see some examples how this can be set up. So as I understand, we already have the results of the poll, and I would say before we start, let's actually look at the poll results. So we do have a couple of beginners, great, and welcome to the world of development, let's say. But of course, we do also have a healthy mix, I would say. So let's look at the next question. Oh, that is great news. Happy to hear that we already have people who are experienced with MongoDB and already using it. I hope you anyhow can get a bit deeper into some functionalities, or maybe it's just a good warm-up or refresh of what you know. And of course, I hope that the ones that say no, at least will get a great understanding of MongoDB and maybe consider it for the next project. And last but not least, the question, who has already set up an environment? So we do have a healthy mix, let's say half-half. Some have already a cluster set up, some have not. Don't worry, we will do that together for the ones who haven't done it yet. So again, the reminder for everyone, not only here on the meeting, but also on the live stream who wants to participate simultaneously, please create an account on cloud.mongodb.com. If you haven't done it yet, you don't need a credit card information or anything like this. And it's actually quite easy and quick to do. And just while you do it, you can skip this page because we will use that later on. And after we have created the cluster, I don't want to jump between presentations and my desktop on and off. So let me already give you the hint again. If you haven't done it yet, please download the Compass tool. I mean, you don't necessarily need it to perform everything that we are going to do, but I find it much more easier to use, to be honest. And it's a great tool. All right, then we have seen a lot of PowerPoints, so now let's actually look into an environment. So you see here now on my screen, my MongoDB environment, my private one. You will most likely have to create an organization if you're completely new to it, and a project. So I have already done it. I have my own organization and M001 project. And in here, I already have a cluster. If you don't have a cluster, don't worry. Just click on Create New Cluster. And because I already have a cluster, I see this image right on, but you will see this one first, where you can choose where you want to deploy. And since we're in the very beginning, let's keep it simple and start with a shared cluster that is free. Just select your the cloud provider you prefer, and also the region. Of course, I would highly recommend using a region that is somehow close to you. And after you've done that, for now, there's not much more to do besides giving your cluster a name. And when you have done the naming of your cluster, just click on Create and give it 2 or 3 minutes to automatically provision all the resources. Because what's happening in the backend, even though it's now a sandbox, it still works the same way as it does for any good MongoDB environment. What Julian said, you will have 3 nodes, 1 primary and 2 secondaries that are automatically deployed, installed, and connected. And you actually don't need to do anything for that to happen. So let's look into the environment again. Sorry for that. So for you, it will look like that there will be the sandbox label here, and it will be in a yarrow frame because it's provisioning. But while that is happening, you can also make sure that you're actually able to access the database once it's deployed, because the deployment itself doesn't come with any default users or password. Since this would be insecure, we actually need to create them ourselves. So let's actually start with a user. And for that, you are going to go to the database access section in security. And I already have a user created, but if you are missing a user, just click on create a new database user. And here you can actually define different ways how you want to authenticate users. So we can do the standard user password. You can use certification-based authentication. And for a production use case, for example, in a company, we can even integrate with the existing Active Directory or LDAP user management tool. So for now, I would recommend just stick with a simple user password. And the first user, you probably want to have a read write to any database user. But later on, you can, of course, restrict the access not only on the database itself, but it's actually based on collections. So you can do a fine granular role-based access control. And once you have decided for a username and password, just add the user, and you are done on that part for now. The next thing is we are by default working with whitelisting, meaning if you don't whitelist an IP address, you won't be able to access any database instance. So just click on add an IP address and either enter your IP address manually. Of course, you could do a 000 to allow access from anywhere, or if you haven't done yet, you will see a button saying add my current IP address to allow the access. And with this done, you can actually sit back now for a moment, wait for your cluster to deploy, and then use Compass to connect to your cluster. And how do you do that? Well, you see that on the cluster itself, there's a little button saying connect. Just click on the connect button, and there you can actually select what you want to connect with. So are we talking about the shell? Are you working on your command line? Do you want to connect your application? And for now, as Julian said, we are going to work with Compass. So I select Compass. And we get this connection string here. And you can see that the username is already entered and the password is, of course, missing. I can simply copy it. And then I actually switch to my Compass environment. So let me pull my Compass in here. Zoom in so you can actually properly see something. I hope that's fine. And now that you have Compass open, it's actually quite easy to complete the connection now with your cluster. When you have copied the connection string, just go in here and paste it. And oh, that's wrong. connection. I didn't copy it properly. Just copy the connection string. Of course, replace the password section with the correct password that you have declared. And I've already done that here. So you don't see my password here. And now you simply click on collect. All right, now we have Compass and it's connected to our sandbox environment. So let me do a quick health check. Did that part seem understandable for everyone, or was there anyone having issues? Maybe also a quick question to Stefan. Did you see any comments on that part? Oh, the question on AWS, Azure, or GCP. It actually doesn't matter. There is no dependencies on any provider. So just select the one that you prefer, or the one that has a region actually close to you. Because since we're working with a sandbox environment, you don't have access to all the regions of all providers. If you would deploy a paid environment, then of course you would have more regions also per provider. So select the one that you prefer. And the good thing is the database underneath is still the same. It works the same. So there's no difference depending on what you use. Okay, great. So since I don't see anyone complaining that he's completely lost and it's not working for him and swearing or whatever, I assume everyone is fine. And we can actually continue working with Compass. So Julian already explained that Compass is our tool that we use to provide a visual way to work with the database. Of course, you can do that all with the command line as well. But with Compass, we have a neat way to look into our data. So for our task later on, for the live challenge, we will work with one specific collection, and we will later on talk about how you get access to this collection. And we will look into the sample mflix database and into the collection movies. And as you can see, now I can see all my documents. We can see that, and that is very special about documents. For the ones that are not used or coming from the relational world, the special thing about documents is that we can actually use nested information. So if you look at the movie, for example, it has a plot, it has also genres, and it might actually have multiple genres. So we can actually provide an array rather than just a string connecting all the genres separated by a comma or anything. We can just deploy an array. So for this movie, for example, we only have one genre, but I think this one, for example, has two genres. And it is simply an array where we can add as many genres as we would like. Of course, not going to talk about unbound arrays. That is another topic for next week. But in basic, it means you can put a lot of information in a nested way. And that is a complete new concept when you're coming from the relational world. So what can I do now on Compass with my schema? Well, I can actually look into the documents manually, but up here I also have a schema section. And there I can actually click on Analyze my schema. And what it will do, it will look through a sample of data set and give me an overview how my documents are structured. So I can actually understand how the different fields are structured, what data types I'm storing, and actually take a deep look into how they look like. And I also see what values are in these fields. So for example, you can see now that you didn't see before that every movie has a field called awards. And in there, we have how often has a movie been nominated. You see how many it has actually won. And what you can do now, you can say, okay, I want to see how many movies, or I want to look into the movies that have won a certain amount of time. I can click and drag and release. And what you can see now is that up here, there has been a filter created. And I can click on Analyze again. And now I will look at documents that fit into that specific filter. And of course, I can reset the whole thing again and look at my document in general. The next thing is I can do explain. So meaning I can actually see how my query is performing, which steps I executed, and which might be the issue that I'm, for example, seeing slow performance on a specific query. I see my indexes, which we are going to look into later on. And as Julia mentioned, you can actually create validation rules in here. So you can actually say that you want specific fields to be included or need to be there or have a specific type. It's up to you, basically. All right, then I would say before we continue on how to work with Compass, I hope that everyone has a cluster node provision. And I guess you'll actually want to have access to all these interesting collections and databases. So let's go back to our environment again. And here you hopefully have this done and it's provisioned. What you can do now is click on this menu button here, and you can say load sample data. And this will actually import the databases that you have seen on my Compass environment. And once you click it, just give it another minute or so for all the databases to be imported. Going back to Compass. Now, how do I actually edit documents and how do I work with them? So basically, we have multiple ways. One, of course, with our application itself. But for today, you can either use Compass as a UI tool, but you can also connect to your database instance directly without using the terminal, but actually clicking this little button here, which says Mongo SH beta. So this will actually give you a command shell directly with your database instance. And now let's look at some basic CRUD operations with the database. So first of all, I of course want to be able to create new documents. And there are two ways how I can do that. One is I can do it with a UI, simply say insert a document. Either I can import an existing JSON or CSV file, or I can manually enter all the information. And basically what I would do is I can enter my JSON here, or I can even do it this way, where I can then manually type everything. The other way would be to actually use the shell, which will be more similar to how you would do it from an application point of view. So first of all, I will use or select the database I want to work with. In my case, it's a sample underscore mflex. So I will say use sample underscore mflex. And now I have selected my database, and I can now list all the collections that are available. And now I see all the collections, so it's very similar to what I see on my user interface. Luckily, I would be very surprised if it would be different. And now I can actually work with the movies collection. So what I do to insert a document is db.movies, and then insert. I can insert many documents. I can insert one. Let's keep it simple. We just take the one. And now I define the structure of my document that I want to insert. And as mentioned, underneath we're storing it as a BSON. But for now, the structure, how you define it, basically looks similar to a JSON object. So let's say I want to add a new movie, and it will have an attribute called name. And this name will be Timo's movie. So my own movie, why not? Always wanted to have one. And I will give it an attribute, say year. So which year was it actually released? And since this will not be a string, this will be a number. So I will just simply enter a number. And this way I can, of course, add arrays and dates information and so on. But that is basically the way I would do it. Since I've now structured my document, I click enter and I get acknowledged. And now my document should be in the database. How can I find it now? Well, again, there are two ways how I can do it. I can simply enter a filter here and search for it. So for example, I know its name. So I can say name, and the name is Timo's movie. Oh, I need to spell, of course, my name correctly. And we see now here the document. We have the name and the year. And I can do the same, of course, on the console. Again, saying db movies.find, which is the command we use to look up documents. And define my filters again that I will use to look it up. And in this case, it's the name again and this way. And we see that we've found the document. The interesting thing now is this find is that, as mentioned, we don't only have a single value and attribute and a single key value pairs, but we actually have arrays. So how do I actually search for data that are stored in an array? There are different ways how to search for them, and let's go into depth on how you can look through an array and build different commands or different conditions for these arrays. So one thing is, if I want to look at all the movies that have, let's say, comedy as a genre, but I don't mind if they have other genres as well. So I just want to know that they do have at least comedy as one genre. I would say genre. And similar to the way we did it with the movie search in the filter, I just enter comedy. So what this means is it will look at any document that has comedy as a genre, but it will also include documents that have additional genre included. Now, maybe now I want to say, I don't care for any movies that have additional genres within them. I only want to look at documents that are only comedy. So how would I do that? Well, I would basically say genre and then add the brackets before that. And this now actually means that we are looking at documents that only contain this specific genre or this specific data. So we are not allowing any additional genre information. And if we search again, we see now that all the movies that we have received only have one specific genre. Let me close this for now. All right, now there are even more queries I can think of. So let's say I'm not sure what I'm looking for. I might be in the mood for a comedy or even a drama. I know it's a weird mix, but happens on a good movie night. So how do I do that? Well, for that, we have actually specific operators that we can utilize. So for this one, we will use an operator that is called $in, which actually means include. So I can see it's already suggested here. And what it takes is, it takes an array of information, and one of these information needs to be included in the array that we're looking at. So again, we have an array that we give on attributes, and we say, well, it should be comedy or drama. So again, we say comedy or drama, and this will now give us all the movies that at least have comedy or drama in that genre. The next thing would be, I I did a mistake in my search. I'm actually not looking for comedy or drama. I'm looking for something that is comedy and drama at the same time. It's a bit of a weird mix again, but I'm sure there is a movie for that. So now I'm actually not using the $include, but I actually mean I don't want to match one of the attributes. I want to match all of the attributes. So I say $all, and that means I'm looking for movies that have comedy and drama in their genre. I click on find again. And now I actually have movies that include comedy and drama in the same name. As I said, it sounds weird, but there are movies who contain both. So what is the next thing we can do? One is actually filtering on values, of course. So now I want to look at movies that have a specific rating, because as you can see, we have an object called IMDb. IMDb is a moving rating platform, and it has different values in it. It has a rating, it gives me an information how many people have voted, and it contains its own ID. So now let's look for a movie that is rated above 8.0 and is PG rated. So if I'm not mistaken, PG means kid friendly or something like this, right? I'm not too sure about the rating system for that. So if that is what I'm looking for, let's look how we would filter for that information. First of all, what field information am I interested? Well, I want to know about the IMDb.rating. And how do I access this specific attribute? Quite simple, we use the dot notation. So I say IMDb.rating. And now I don't want it to be exactly 8.0. I said it should be above. So it could also be 8.5 or 9 or whatever. So it would be wrong to just enter 8, because I would only return movies that have that specific value. So we are looking again as a function we're using, which means greater than, so GT, and say it's 8. So meaning now I will get movies that have an IMDb rating above 8. I can also say I want to have 8 included. Then I just simply add greater than or equal. So greater than equal, an E. And now I have movies in there that have 8 also as a rating. And now I mentioned I have an additional condition. I want a specific rating, in this case PG. How do I add this now to my filter? Well, very simple. I add another condition with a comma separated. The comma is always interpreted as an AND condition, so it will match both of the conditions that I enter. In this case, I said rated, and it should be PG. This way now, if I find, I will actually get the movies that have a specific rating or a rating above or equal 8 and have a age rating PG. All right. That is the way how to search for your data on this specific level. But there's one more tool that we have for querying for your data that is even more powerful than just filtering based on certain fields and values. And that is the aggregation framework. And before we are looking into how to work with it, the question, can we use operators like equal or bigger or smaller? Julian, can you take that? So, or you can add. So in general, no. In the filter, we always refer to the mathematical operators. The reason being, there's a certain, as you have seen, there's a certain schema on how we define our query or our filter, and it's always this JSON-based key value methodology that we're using, and that is why we need to use these mathematical operators rather than these, let's say, logical operators on programming level. because you actually want to refer to a function then that is used within the database. And one big aspect to it, I know it sounds a bit weird that we prefer to do it this way, but that actually allows us then to query the data on the database in a more efficient way. So meaning with this way, we actually get a very high performance and on the filtering mechanism. Julian, anything you want to add to that part?
Sounds good to me.
All right. So as I mentioned, I want to talk about the aggregation framework, and let me give you a short introduction before you actually get to do some hands-on work with the aggregation framework yourself. So what we've seen before, this .find notation, which is used to do a simple search on specific attributes, is already good, but it's limited on what you can do. There's actually much more you can do with your data, and that's where we use the aggregation framework. What is the aggregation framework? Well, aggregation framework is how you can not only filter your data, but manipulate it and create new information from your data and provide it to your application without the need to store them locally on your application, do a certain calculation, and then use it. So what is important to understand about the aggregation pipeline is, or about the aggregation framework, is that we work in stages. So rather than having in a traditional system a query that grows from the inside, so you first start with your select star from, then you start to add a condition, then you say, okay, select star from database A, join B on, and having this, let's say, implosion of a query. We rather do it in stages, meaning we start thinking in a very simplistic way on, okay, what do I need to do first? What is my second and third? And what is my last step maybe before I want to return my data? So you can see here now, for example, on the bottom, I like this visualization. You can imagine that your data is streaming through the stages. And after each stage, your data is transformed in a specific way and handed to the next stage. So actually, why do we use aggregation and how do they look like? Well, it basically goes in the direction what actually Raul just wrote in the chat. As a developer, I find it quite hard to write JSON format queries. We will look how we can help with that, but let's be assured that at a certain point, this find function that I used previously is not very suited anymore. And that is the point where you start to actually use the aggregation framework. And let's look at one customer example that we have. So let's say we have a database containing user information in the sense of we have each information has a specific user ID or customer ID. We have a specific amount they ordered. And we have a status on this order. So this order might be approved or D for declined, as we see down here. And our business question is now, well, how much is actually ordered by which customer that is approved? So we want to know how much of our orders are approved. And on these data, I want to know how much value the collection of all orders per customer have. So what are my stages I need to look at? Well, the first one I do is a match stage. So I say, I only want to look at orders that are approved. I don't need to think about the declined one because there is no money that I've gained from that. So the first I do is I do a match on status A. And that will give me a new data set only containing information that have status equal to approved. The next question is, I want to know how much money each customer has already spent on my website or with my ordering system. And how do I do that? I just group my existing data on the customer ID. So I have a group stage. I group on customer ID. And what I also have is I create a new field called total. And this total will basically create a sum on the field name amount. So what this does is it means that when it has grouped the information on a specific customer, it will do a simple addition of each amount value for each customer. And then I will actually end up with the total amount each customer has ordered. So that was just one example explanation. And in a minute, we actually will look at the movie collection to give you a more one more example, because as I said, this framework is different on how you're used to query your data. But once you have embraced it, it can be very powerful to use and actually take a lot of work from your application in the end. So the aggregation framework, we need to distinguish between pipeline stages, so certain operations we do on the data set. So we have already looked at the match stage, and as we will later on also look at, for example, the unwind that is specific to arrays. And we have different mathematical operators that we can use. And a few we have already seen, which is, for example, the dollar greater than or greater than equal. LTE is, of course, then the opposite, so less than or less than equal. And with these two in combination, you can actually create a lot of great queries into your database. So let's look at another example where we start with the question. So we say, what are my top 3 directors measured on the award they've won? And how many did they actually win? So I need to think, okay, what information do I need? First of all, when we think about our data set again, the directors is an array containing a list of director names. So meaning, first of all, I need to have a dedicated data set per director, because now I actually want to look at them as an individual. So the first thing I do a $unwind on the field directors. What does $unwind do? It will create a separate document per element in my array. So as I said, if I have, for example, a movie and it has 2 directors in it on the array, it will actually create 2 documents, each with one director as a single value in it. So this way I will actually remove the array from the document. And why do I do that? Because now the next step, what I can do is I can group based on the directors. So first of all, when I did it unwind on the directors, I had 1 document per movie per director. Now, when I group this all together, I actually get all the movies that each director has done. And because I want to know how many awards they've won, I have a new field that I define that is called wins. And again, it is a sum of the awards that this director has won. And this information can be found in the awards.wins. And now I have the amount of awards each director has won. The last thing I need to do is I, of course, need to sort. And -1 means I sort in a descending order. Since I only want to know who are the top 3, I do a last stage called $limit, which means I will only return the 3 top directors. And after I've run this aggregation framework, my application will get an JSON like response containing only 3 directors and the corresponding wins they had on the award side. So now I actually, on my application side, don't need to do any further filtering or logic, because I can simply now represent this answer to my application. All right. Now we will actually do some live challenges. And for that, I hope everyone is ready, has his environment up and running, and the sample data are imported. Does anyone have issues or had issues with that? Please let us know now. I would be very disappointed if someone couldn't participate because he had some issues and we didn't talk about it.
And maybe in the meantime, this is Regine from Marketing MongoDB. The swag is waiting here for you to be won. So just to kind of introduce the rules here. So whatever result you get to with your programming skills you just built up, just put that into the chat. And we will see the first who gives us the result will win. We have a couple of challenges coming up. So there are many possibilities to win. Yeah, thank you so much, Timo, for sharing that. And I will then reach out to you in order to get your email address so we can get things shipped to you ASAP. So that was the Werbepause here. Okay, sorry for
commercial break. Yeah. All right. Because now we have like half an hour left, and in the next half an hour, I actually don't want to talk too much because it's now for you to work with MongoDB. Just one small hint: if you want to provide us the answers, kindly use the chat function and make sure that you actually use the option to send to the panelists directly, so not everyone sees the result and everyone has the chance to take a shot at it. One last thing we will actually do before we start with the first challenge, because we said we are also going to talk about indexing. And Julian has talked about indexing, but we haven't done much about it since then. One last thing we will do in our cluster environment that's already there. We will actually go into our sandbox environment and go into WeAreDevelopers or whatever you have named your cluster. And again, there are a lot of metrics that you can track, but we don't care for that now this much, but rather go into the collections view where we see all our collections. And we will go into the sample mflix database and into the movies collection. Because we will now create an index, but not just any kind of index, but let's say a special index, and it's called search index. What does search index mean? It means you will actually be able to use Elasticsearch query capabilities on the same database that you're already running. So you don't need to create an additional database. And while we are creating this index, the database is not down or anything. We just simply click on create. We can now actually define a complex filtering on what kind of indexes we want to define. And they're very powerful tools, like what kind of Elasticsearch engine do we want to use, or Lucene-based search engine we want to use. But for now, due to the time, we will keep it simple and just stick with the default values and click on create. And we can close this. And while this index runs, we can still work with our MongoDB. It doesn't affect our live challenge at all. But we will have a challenge where we'll use this index later on. All right, then let's jump back in here and actually start now with the challenge. So the first challenge will be, what is the average IMDb rating of movies in which Leonardo DiCaprio plays a role? So you see, it is not a very simple question in that sense. Let me give you some hints. Of course, we are looking at the collection movies in the mflix database. We will need to utilize the group stage later on, and we will need to use the $unwind stage, because the information that we are looking for is actually in the field called cast. And look into the mathematical operations in order then to create your fields. And I highly recommend, if you haven't done it already, open up our documentation for the aggregation framework and just put it on the other screen for your orientation. I don't consider that as cheating, since we're in the very beginning of working with the aggregation framework. So I would say I start 5 minutes from now to give everyone a chance to actually try it themselves. I feel the need to provide some kind of music with this. It's so silent. But I hope everyone is successful at trying to solve this riddle. And again, once you have an answer, post it in the chat to us on the panel list. Thanks, Julian. That is the documentation for our aggregation framework. Feel free to use it if you feel like you don't know where to start.
Do you want to use the time to answer one more question coming in from the Q&A session, or do you
Sure.
prefer to do it at the end?
I'm happy to do so. Like,
Okay.
hopefully I'm not disturbing people too much, but I think...
Yeah, exactly. That was also my thought. So it's up to you.
Not sure, Timo, what do you think?
Yeah, let's do some questions. It's a good use of the time. Otherwise, I would start singing here. I feel awkward having the silence here.
Okay, so for everyone who wants to focus and can't take us talking, just mute, just like silence your speakers for a second whilst we're going through the questions, and we're going to ping you in the chat before we continue with the next challenge as well.
Okay, so there's stated the last answer was interesting. Why it is more performant to operate with your own created functions rather than easy to understand operators like creator or equals. The guy is interested in the mechanism behind it.
Yes, one second for short. If you don't see a panelist option in the chat, that is most likely because we are in a normal Zoom call, not in a webinar call. Can you please just send your results directly to either me or like, let's say you just send your results to me and I'll forward it to Regina. So just choose my name in the chat. So rather than sending it to everyone, just to me. And then I can forward this to Regina. Okay, second. Okay, so with respect to the operator question, like technically speaking, I think the main part really is the syntax component. So when we're thinking about like how our queries are structured, we are always having this way that we are encapsulating certain subsets of the query into a JSON object. So what we do have is simply the structure where we say, okay, I want to have a specific field, I have a colon, then I have an object, and then you have, for example, greater than a certain value. And just due to the fact that the query language has always exactly the same way of how it is being structured, we just depend on the fact that we have this way of structuring our queries, because otherwise we would have certain breaks for specific operators. And then it would be like in the real life with normal languages that there are exceptions for exceptions for exceptions for exceptions. And specifically, for example, in the German language, there must be an exception to every rule, otherwise it's not a rule. So we really tried to make the structure of the query language as easy as possible and as comprehensive as possible. And once you have like wrapped your head around it for the first time, it's actually really nice because you can read it stage by stage, specifically with aggregations, and then you kind of like start to like the way that it is, because you can read through a statement from top to bottom and you see exactly how the data is processed, similar to how it's viewed in the aggregation pipeline builder. So it was a very long answer to a very simple question. So that's mainly syntactical reasons. We're coming to the end. Timo, it's time to open up the solution. You're still muted. I needed to say that. That's the sentence of 2020. You're still unmuted.
Yeah. So whoever is playing Zoom bingo, there's one more to go that I fulfilled on that part. No, great. All right, time is up. And let's actually look how you solved it. I think, Julian, there were some people who already got the result. So
yes,
great.
there are
Happy
some
to hear
rules.
that.
Yeah, there are some
The
results.
worst thing that could have happened, having no one solving it. So that would mean we have done a horrible job at preparing the questions. So let's actually look at the aggregation that we need to build. So we are now in our movies collection, as I mentioned, and we are now using the aggregation field on Compass. Just be aware, for the ones that weren't able to use Compass for whatever reason, you can also do aggregations on the cloud environment directly. So if we go back here, there is actually a way to say, okay, I'm in this collection here, and I can build my aggregations directly here, just in case you had any kind of port issues or whatever with Compass. So let's go back to this one. So our question was, which movies, what is the average rating we got on movies where Leonardo DiCaprio is part of the cast? So there are two ways how we could do it. Similar to the director one, we could say, let's first unwind and then group all the movies where Leonardo DiCaprio is then the part of the cast. But since we don't care for one individual actor, it doesn't need to only be Leonardo DiCaprio. We can actually use a match. And we have seen match already a couple of times. So let's start with a match and filter our data. So for this one, we just say cast, and it should only contain Leonardo DiCaprio. I hope I spelled him correctly. It's always one of the risks to misspell him. But yeah, it seems I'm correct. So now I have all the movies where he's actually part of the cast. So the next thing I want to do is, now I have this IMDb dot rating for each movie, and I want to know the average rating he got. So what I do is I do a group, because I want to summarize all the information that I have. And now there's a little trick, let's say, that the people that have looked into the documentation have seen. Rather than providing a field name, I say null. And what that means is I will actually group all the documents together rather than by a specific field. And I will say, I will create a new field that I call average rating. And this time, the last time we looked at the query was the directors, we did a summary. So, or a sum, not a summary, but a sum. But this time we actually want to know the average. So again, there is a mathematical operator called AVG, $AVG. And there's a specific field we want to do this average calculation on. And this field is the IMDb dot rating. And why do I need to use the dollar now in here? Because in this case, we're actually accessing the value directly rather than the field reference. So this is why I need to include the dollar in this field name. And yeah, with that, I got the average rating of 7.48 for Leonardo DiCaprio's movies. Great. So congrats to the ones who got that. Let's look at the second one. I hope now that we have done one together, everyone feels like they got a better understanding what they need to look out for and how to do the querying. And start with the next one, which is, how many actors have never played in a movie that has won an award? And again, we're using the collection movies. And this time you will need to look at each actor individually. So I highly recommend using $unwind, similar as we did with the directors, and then group the data and do some filtering on that data. All right, again, 5 minutes from now, and if we have any question that we want to address, this would be the time now.
do we still have any open questions, or have we answered all of them for now?
It seems at the moment you just satisfied everyone.
Okay, great.
Great, Timo, your instructions are comprehensive.
I hope.
Or we are just very boring. That's either
Yeah.
side. Either interaction levels are just low and everybody has been falling asleep. And hopefully that's not the case.
Now, any feedback on the question that you just worked on, also on the chat, is more than welcome. Let us know. Do you think it was too easy or maybe too hard to start off with? And Julian, of course, let me know when you get some responses on your side.
Sure, I'll forward them directly.
So again, the question where can I could post the answer. So I think you need to be here with us in the Zoom chat or in the Zoom session. So you cannot populate the answer or your answer from the outside, just looking at the stream on the WeAreDeveloper homepage. You need to be here with us in the Zoom, and therefore you needed to be invited.
I mean, technically speaking, if anyone wanted to, you can also shoot me an email. I'm not sure, Regina, what do you think?
Let's always be flexible in the hips.
Like a document model, right? So yeah, if you want to provide an answer, you can also provide an answer via email. Let's just go this way as well. So yeah, the first answers are already coming in. It's great. Let's check whether they are correct. I'm just forwarding them to Timo.
Then take this option for our third challenge, and then also make sure we put your email into the chat, and so everybody knows which email address to use, right?
Sure. Oh yeah, my email address. That's a good point. It's first name dot last name at mongodb.com. So it's julian.storz@mongodb.com. I'll also share it in the chat for short. Let's check whether this is actually correct. Yeah, that looks good. Typos would be unfortunate, no.
Oh, here, an interesting question, technically wise this time again, fortunately. What's performance will be querying database with size of 250 gigabyte?
250 gigabytes?
Yeah, 250, yeah.
Okay, so that's a very generic question, which is hard to answer. I mean, obviously, since we are all here from the NoSQL side, I can answer that it should be better than relational, but like, obviously, that's obviously nothing that I can just take seriously. So let's answer the question directly. Given you an indication on how well and how fast your query is going to be just based on the data size, will be very difficult because it depends on your structure. It depends on what is fast for you. So does fast for you mean like 500 milliseconds, 300 milliseconds, 10 milliseconds? And then it really all comes down to whether you can use an index, whether you can cover a query with an index. So for example, in MongoDB, if all of the fields that you return are part of an index, the full information is taken from the index and delivered directly. So you're going just through memory. We have customers using MongoDB with a couple hundred terabyte. So that would be a little bit more, and they have good performance. But here, really, I would always propose to test it, to just give it a try, and to see how the performance actually looks like for you. Everything else would be just not professional on my side to state, I think, because I just don't know enough about the background. But to generalize, performance will be obviously good.
All right. With that, let's go back to our question. The timer is up, and we actually have different results, and I can already imagine where they're coming from. So let's actually look into how you write this aggregation framework or this specific aggregation. Oops. Nope. This was not the plan. Come on. So let's go back to Compass. And I said the question this time was how many actors have not won an award. So it's very similar to what we've done with the actor. We first need to similar to the ones we have done with the directors. We need to separate all the actors and have one document per actor in order then to filter who has won a prize or who hasn't. So what we first do is we do a dollar unwind again. And you see there's a lot of fields added, but they're all optional. So for now, we can just simply delete them. And we provide a path. In this case, it is cast. And of course, that is a reference. So let's see. Why don't you want to do what I'm saying you should be doing? Let's do it a bit more simple. It's always the same with, I don't have that one. Unwind. Julian, help me please from the outside. It's always when you're typing, you're doing mistakes, and that is stupid. So we're doing unwind on cast.
You need a dollar cost.
Of course. We need all the values in, yeah. So now we actually have one document per actor. So we see now cast is not an array anymore, but actually has its own direct value. And this actually allows us now to do a group. And this time we simply group on cast. And we do have a field called wins. And this one
should dollar cost, yes.
Yeah, the same again, of course. And this time we do a sum again. So we basically add all the values that are stored in the awards.win. And now we actually have all the actors and how many awards they have won. And we wanted to know how many have never won an award. So we do, again, a sort. And we sort by wins, the new field that we have created. And we start ascending. So we type 1. Or what we could also do is we could simply do a match. So we filter by the ones that have 0 wins. So you see, sometimes there are many ways that lead to the same result. And last but not least, because we actually want to know the amount of people, we can do a count and let's call this in total. And now we have the amount of actors that have never won an award. So that are 10,185. So, as I said, there are different results coming from different areas. And one thing is always important to make sure that you are referring to the value within the field. So it's important to have this dollar awards and not just awards.win. That is, I think, one of the, let's say, downfalls that can happen on that part. All right. Looking at the time, we have 5 minutes. I would say we don't have necessarily time to do all the challenges that we have prepared, but I will present them to you maybe in your free time. You feel like doing some, but testing your knowledge. So one thing I will lead you through is actually how to use the search index that we just created. So let's say we have the question, and each movie has a field called.
Timo, just for 1 second, I think since we don't have time to go through that, is maybe people just want to take a screenshot, do this at home, and just send me an email on the email address that I provided in the. And we're just taking the first one who sends me the correct result via email, and I'll provide it to Regine, and then you obviously get exactly the same chance as the others as well, because obviously this is a time issue, and I don't want to take that opportunity away from you. So please take a screenshot, just answer the question to my email address. I'll forward it to Regine. The first one who answers it correctly will get the swag.
And the email address again is julian.storz@mongodb.com.
All right. Yeah, fair enough. Good point. So everyone, please take a screenshot who wants to solve this later on. Just as mentioned, my hint on this part would be we're looking at the $search stage, which will utilize the search index that we created previously. So meaning it will actually allow you to do a context-based search in text rather than just a simple value match, let's say. And the second one that we have prepared is one where we would actually look into the ability to join fields. So please take a screenshot if you want to solve this. Again, this time the stage is $lookup. As Julia mentioned, that is the way how we do joins in MongoDB. A very powerful tool. And just so you know, I know the movies and metrics has a field called amount of comments or number comments. But that's not the one we're looking for. We are looking for actually the amount of comments in the collection comments. Sorry for this mistake. It should be comments, not movies.
So maybe you guys also want to answer the, it seems, second question. And these are, I wonder your opinions about storing time series data, e.g. IoT sensor data in MongoDB. Can you compare with time series database pro-cons point of view?
Mm-hmm. That's a very, very nice question, because I get this question a lot lately. Seems like there is a lot of demand for IoT. There's a very nice talk that I held with Dr. Christian Kurze this year, actually, on our global conference, MongoDB Live, on IoT. I will share that in the chat as well. So currently we see quite a lot of adoption of time series in MongoDB specifically as well, due to the fact that we have this flexible document structure. And there is a way of storing documents in MongoDB that are optimized for time series. We call it bucketing. And there will be also more things that we add over time in the upcoming versions as well. When it comes to time series and analytical features, this is one of the priorities of our new CTO to enlarge the analytical capabilities of MongoDB. This is also stated in one of the articles from him. And yeah, so technically there are a lot of adoptions of this. Bosch using MongoDB extremely extensively for IoT. This can also be found on the internet if you're looking for MongoDB and Bosch. There you'll find some resources, and I'll post the 2 links into the chat now.
Okay, great. Maybe Regine, you may want to put the email address from Julian also here in the chat. That is also an ask from the audience. And Julian, for you, the last question. Is there a major update for the MongoDB Swift iOS driver coming soon, including more documentation and examples?
I would need to follow up on that. I'm not a Swift guy. Timo,
Okay.
maybe you know that. I don't know, sorry.
No?
No,
Okay.
sorry, I'm also not on Swift generally, so I would need to check myself.
Okay.
I can't be expert on all the programming language in detail.
That is a fair statement. I know that.
Sorry for that.
Perfect. Okay, guys. So then from our side, a big thank you to your or for your great workshop session, 2 hours long. It was very insightful also to me. So I really appreciate it. I think you covered all the questions with good answers. And for the audience, I just want to emphasize that we are now done with the workshop session coming from MongoDB, and the main part of the day with the extensive sessions on sessions will start at 12:45 p.m. CET, introduced by Margaret Schramberg and also Amelie Groß from the Austrian Federal Economic Chamber, and we'll start content-wise with the talk at 1 p.m. CET, database on Kubernetes, why you should care. And another last point I want to make, if you are interested in winning a 200 euro Amazon voucher, you can easily click on the banner here at the bottom of the live stream, and you can set your contact details in there and participate in the tender. So from my side, again, thank you very much, Julian and Timo, sorry. And yeah, hope you enjoyed the session, have had fun. Yeah, maybe we see ourselves in a later point in time in another event.
And hopefully in person when everything goes back to normal. Stefan, thank you very much for hosting this. Thank you very much for having us. Thank you, your developers. And yeah, looking forward to seeing you all, hearing from you, and collaborating in the future.
your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
When magnetic fields move and electrons start flowing. When you feel that anything is possible. When the night can turn into day. Then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
Illwerke VKW. Energie für Generationen.
So, just one thing to make sure that you don't get lost. If you're watching this on either Facebook or YouTube and you want to see the afternoon program, you will now have to head over to wearedevelopers.com/live-week and watch the stream from there, because this stream will now end and then we will try to get some food and something to drink in the break, and we will be back in half an hour. See ya. Bye.